All right, so this is a summary of the functional groups lab. Basically, what we did in the lab was we had a whole bunch of different odors in different microtubes because functional groups are just common shapes that repeat over and over again in molecules. So, for example, scrolling up to the lab, if you notice that the last thing we smelled, these three, right? They have this particular shape in common for these particular odors, right? So oftentimes things that are minty in their odor or taste will have an oxygen double bonded to a carbon. We call this functional group or this common repeating shape a ketone, right? So we would kind of draw it like this. And the squiggly line on each side just represents the fact that this ketone, right, to the left and to the right, this part of the molecule might look different depending on what molecule we're looking at. But the common shape that a lot of molecules that have a sweet taste or odor will have this ketone shape or functional group. So going over all of them, aldehydes have this particular shape, right? Esters have this shape. Alcohols and phenols, you can split them up into two different categories. So alcohol would just be an OH or an oxygen bonded to a hydrogen. Phenols smell kind of like herbs and they have this hexagon shape, which we call a benzene ring, with an OH group or an oxygen and a hydrogen directly attached. Terpenes look like this. Ketones, as mentioned earlier, have this particular shape, right? So, given a summary of what happened in the lab, your goal down here is to identify which functional group or functional groups, plural, are shown in these particular molecules. Notice some of these structures are drawn in the structural formula where we see the carbons and hydrogens. So you need to recognize that, hey, even though I drew it like this, if I were to draw out the carbon, it would also potentially look like this, where C is at the vertex, right? So here, there's another C or a carbon here. And for the phenol, there are 6 carbons within this hexagon, so on and so forth, right? Every time I see a corner or a vertex, that's where the carbon is at. Recognize it might be kind of difficult picking out or holding these images in your head. So you might want to notice that all of them have oxygen. So since all of them have oxygen, I'm mainly going to look for oxygen, and I notice that this is O double bonded with another O. Right, so scrolling back up, I'm going to look for something where I see O double bonded to another O. So I see that here, O double bond carbon O. We call that an ester. So going back to here, O carbon double O. So there's an ester as a functional group here. You might notice that there's another functional group, and that is O bonded with H. Right, so scrolling up, O bonded with H, we call this an alcohol. So another potential answer is that you could have also said alcohol, right? So there could be multiple correct answers or just one, depending on the molecule. Try to find at least one functional group per side, or per molecule, excuse me.